nice to see you all. So yes, this talk is about a project that has recently finished. It's a collaboration with the UCL, and it was about maths applications and young children's learning. I thought that before I go into this project, I give you a very brief overview of what the projects happened before this project, because this is actually one of the areas I'm particularly interested in. So back in 2015, I got the BIRA funding. BIRA is the British Educational Research Association, and the project I did back then was to understand the impact of a science game on young children aged 4 and 5 years old. And the findings from this study showed that the 5 years old were performing much better compared to the 4 years old when they were playing the game. Then this was followed up by a grant from British Academy, the Evaluate project. And here the idea was to understand the impact of maths applications on young children. And we ran randomized controlled trials in 3 schools. So we compare pre and post tests. And despite the fact that the post-test scores were much better compared to the pre-test, this was the case for both the control and the intervention group. So in a way, we concluded saying that using the apps we included in the design or practicing in the classroom in a traditional manner, I would say, brings up the same benefits. The only thing I want to emphasize from here is the design of the apps we used. We call them drill and practice apps, and it's possibly what comes in your mind at the moment are those basic maths apps where children are doing calculations, additions, identify numbers. So it was this kind of apps that we tested, and we found that they were equally good to what is happening in the classroom without the use of apps. Also, the other outcome of this project was this framework. So what I did was to review existing studies, trying to understand what the design features of the apps hinder or help learning. And I concluded with those 8 features and the conditions, specific conditions under which they help or not young children learn. I'm mentioning this because in a way, the study I'm going to talk about builds on this framework and is elaborating this further through a systematic analysis and the content analysis. So the study I'm going to talk about was funded by the Nuffield Foundation. It started in 2020 and finished last year. The PI, the project investigator, was Laura Othwaite from UCL, and some other colleagues from UCL were participating. And our advisory board was a quite interesting group of people with expertise in teaching maths at schools or designing technologies for learning, and also specific expertise in conducting systematic reviews. So for me, it was a great learning experience interacting with those people. So the rationale behind the project was that, as we all know, there are more than 500,000 apps, educational apps online. More than 70% of children are actually using tablet devices, and this number is even higher if it's country specific. And we have a significant portion of teachers using apps as supplementary teaching tools at schools. The question here is, how do you decide which app to use with your children or with your students, or if you're a policymaker, what apps should you recommend for use? Also, it's really hard to find good quality educational apps to support teaching and learning. And because of those gaps and difficulties we are facing, we focus on our project, the aim of which was to provide evidence of which maths apps work, how and why they work, in order to help mathematical attainment. So the project had 2 phases. The first one was a systematic review in which we synthesized the evidence of maths app impact on young children. The age range we were interested in was the 3 first years of compulsory school, and this is age 4 to 7 in the UK, in England, and 5 to 8 in the US. And then the second step of the project was a content analysis of the apps we found in the systematic review. And by content analysis, I refer to analyzing the content of the app, the design features of the app, and how these may support or not the children's learning. So I will go through the process. So the first step was a systematic review. We followed the PRISMA principles of doing a review, and we included the studies that assess the impact of maths applications. They were used either at home or at school. The children were, as I said before, in the first 3 years of schooling, and the outcomes were focused on mathematical attainment as the key criteria, plus they were examining issues like enjoyment and motivation, but this wasn't the requirement. Our focus was to assess mathematical attainment. We started with more than 5,000 studies, and we ended up, after we followed this criteria, with 50 studies included in the systematic review. So our key findings, in terms of the method, we found 20 randomized controlled trials and 13 quasi-experimental designs. So mainly was experimental methods used in those studies. The populations now, the main focus was typically developing children at different attainment levels. Some studies, few in number, they were supporting underachieving students in maths and also students with special needs. In terms of the findings now, and by findings I mean what is the impact of the examined apps on children's learning and development. The majority, 21 of the studies, showed positive results in favor of maths apps. 8 studies had mixed results, and 4 studies found no differences between the control and the intervention groups. The measurement of learning happened as expected, I would say, right after the intervention, with only 5 studies, including a delayed assessment, which was like 1 month up to 2 years after the study took place. 13 studies assessed non-attainment outcomes like enjoyment, increasing motivation, experiencing flow, and whether children preferred the use of an app as opposed to other methods of teaching. Now, the final remark from our final remark from this systematic review is that we found only 2 studies that we could characterize as presenting the highest standards for rigorous research and rigorous methods. So those 2 studies had used an RCT with a large sample size. They used standardized measures of to measure mathematical abilities, and also they reported statistics that would enable us to calculate within subject effect sizes. And actually, I would say that most of the times it's really hard to find the statistics like mean and standard deviation to calculate effect sizes. And this was also evident in this systematic review, as only 2 studies out of 50 had those characteristics, I would say. So we are encouraging researchers in the future to design, to consider all those aspects in their design and try for the highest standards in doing the research with apps and young children. Now, the second phase of the project was a content analysis. As I said before, we had found 50 studies which we included in the systematic review. In those 50 studies, 77 applications were used in the design. And out of those 77 applications, we used 23 in our content analysis. So now what is the aim of this content analysis? We tried to see what are the active ingredients or mechanisms or a combination of ingredients that are present in a maths application that has a positive impact on learning. And also, how do those ingredients relate to our understanding of mathematical learning as described in current theories? So what we did, we followed the 3-step process. First was the content analysis of those 23 studies. The way we chose those 23 studies was based on these 3 criteria you see there. The apps should measure maths attainment. The studies we should be able to tell the impact of individual apps on learning. And I say this because in some studies, the researcher used 2 or 3 studies in their design. So unless there was a way to disentangle, I would say, which impact is for which app, we excluded the study from the design. Also, those apps should be commercially available, and you should be able to access these from the Google or App Store. So the first step was to code those apps, and I will show you the next slide. Just briefly, I want to say here, and I will come back again later on, is that after this step, we did what we call the qualitative comparative analysis, and then a coding analysis of the top 25 apps. So I'll go back to the content analysis. The first thing we did was to categorize the apps based on their design. And we had this framework here that talks about practice-based apps, which is they are aiming to develop basic math skills, I would say, and the students are rather consumers of the apps. Game-based apps are like practice-based apps, but they have game elements. Constructive apps, the students are encouraged to explore and manipulate items. Productive apps, students are actually producing something new as an outcome of the app. And the parent-based apps, they are designed to enable interactions between children and parents. So based on this framework, what we found from the analysis of the 23 apps was that the majority are practice-based. And this definition is corresponding to the drill and practice definition I gave you earlier on one of my papers in the other grant I had. So it's like developing the basic math skills, I would say. And then we had a few that are game-based and even less that are constructive, productive, or parent-oriented. Here, I'm not going to read the statistics, but you can see exactly what basic math skills are enabled or promoted through the design of those apps. What I want to stress is at the bottom of this slide, is that more advanced mathematical skills like teaching fractions or place value or multiplication are not present in those apps. They are rarely found in the apps we reviewed from the two app stores, which in a way suggests that what is currently available is only, it could only help children develop some basic maths understanding. So the next step was to play with those apps for 20 to 30 minutes each app and try to see what kind of design features they present. We also reviewed the literature to see what kind of design features were related to learning. And we ended up with these 5 design features you can see on this table, which is feedback, leveling, social interaction, task instruction. And the last one, meaningful learning and solving problems, relates to whether or not the app is relevant or can connect to the curriculum in the US and in England. So just to briefly say one thing about each criteria here, because it's those criteria we use for the analysis in the next step. So feedback was in 2 forms. It was either explanatory or corrective feedback, so saying why an answer is correct or not, and motivational, which is the sort of things like good job or let's try again. Leveling was in 3 forms. One type was programmatic or static. Here, the idea is that the learning content is tailored to the child's understanding, which is assessed on an initial test before they start using the app. Programmatic dynamic is when the learning adapts or changes based on how the child interacts with the app. And participatory or free form, there are levels, but these are rather randomly presented to the user. Social interaction refers to whether there is a character in the app the child can interact with, or whether the app encourages communication with adults outside the app. I mean, task instruction, I think, is clear. What you see here is the crosses is the relationship of those features to existing frameworks. So we try to see whether those frameworks were present in other studies, just to get a sense of what we should include or exclude, but I don't think it's a major thing of this analysis. So the next step was to go through all of those features and count, measure how many of our apps presented those characteristics. So as you can see here, 12 out of 23 apps had explanatory and motivational feedback together. Then we had leveling in the free form in the majority of the apps. Then social interaction was mainly with the use of an app in the app. But what is worth noting here is that there was like a big number of them with no social elements and no social interaction. In terms of task instruction, again, maybe the surprising thing here, I mean, my assumption was that all the apps would have instructions. Yet we found 5 of them with no instructions, and 7 of them presented instructions only the first time you were using the app. So if the child logged off or, I don't know, closed their tablet and used it next day, they couldn't really access the instructions again. And the last point was the relation to the curriculum, which actually a big majority linked it in a way, or we could link what was taught on the app to the curriculum. So our next step was to do what we call qualitative comparative analysis, QCA. So this is a method of identifying the conditions that lead to specific outcomes. So it is used to show evidence of causality in complex systems. So we used it in order to answer the question of which design features are responsible for high learning effects as measured in those studies. So what we did here is that we used the same criteria as before to choose apps from the systematic review from the 50 apps we originally had. Plus, we added the criteria of sufficiently reporting data so we could calculate the effect sizes. And out of the 23 studies, only 8 studies met those criteria. So this number is relatively small to do the QCA properly, I would say. So we had this requirement of reducing how many design features we could include in the analysis. And the restriction was saying that you could include only 3 features in your analysis. So we reviewed literature again, and we decided that the feedback that is explanatory, feedback that is motivational, and leveling are found to be key design characteristics in the literature. So we thought to include these 3 in the analysis. And we ran 2 models with those characteristics. But before we run the models, what we did was to list the 8 studies and then go through all of our design features, trying to get a sense of who of them were present or absent from those apps. So when you see zeros in the light blue boxes, means that the feature is absent, and when you see 1 means that the feature is present. What is worth noting from this table is the 3 blue squares I have there. So we coined this a highly effective intervention or study, one that had an effect size greater than 1. So out of the 8 studies, only 3 studies were more than 1, had effect size more than 1, and those 3 were characterized as highly effective interventions. So when we ran our QCA, we ran 2 models. In the first model, we had feedback broken down into explanatory feedback and motivational feedback, and the leveling is one thing, no matter if this was dynamic or static. And what we found out in this first model was that the highly effective intervention had all 3 design elements present. So both types of feedback and leveling was present in this highly effective intervention study. Then in the second model, we put together the feedback type into one design feature, and we aggregate, I would say, the leveling into programmatic dynamic and programmatic static. And as you can see here, the highly effective studies, they had a combination of feedback for sure, plus leveling that is dynamic or leveling that is static. So what we concluded from this as to which design features are more likely to result in learning or benefit students and support their learning was that we need a combination of design features. And the combination that came out of this analysis was that the apps should provide a scaffolded and personalized learning journey. And this was achieved through programmatic leveling. Plus, they should give explanations of answers and also give some praise to enable motivation. So if you are a parent or a teacher, you should be looking for apps that have those features, as this analysis indicated that these are key characteristics of good educational apps. Now, the last part of our study was to apply our framework to the top 25 apps found on both the Apple and Google Store. for 5 years old. This was the criteria based on which we searched for apps. It was very surprising was that only 18 of those 25 apps had some type of mathematical content. The other 7 had nothing to do with maths, yet they were listed on the top 25 educational maths apps, which is a bit of a misunderstanding, I would say, or at least they don't help parents and teachers pick apps. Those categorizations do not help them pick apps that are for maths. Then out of those 18 studies, only 1 was empirically evaluated. 17 of them were practice-based, as expected, I would say, targeting mainly number and counting skills. 14 had motivational feedback, which is one of the characteristics we say is important. 17 had free-form leveling, but not the static or programmatic leveling, which is actually adaptive leveling we are talking about. 18 had some sort of social interaction with an in-app character, and only 4 had instructions of how to do a task. Here is a table showing the details of this analysis. What we concluded from that is that what is available online does not really reflect our best practices in how we could design good quality maths apps. Also, there are limited options of high quality apps one can access from in the 2 stores. So my very last slide has to do with the recommendations we gave following this study. We gave some recommendations to parents and teachers, which have to do with understanding what a child knows, what skills they have, and how the app could actually help them develop further. The second one has to do with how the apps are integrated into the curriculum and to the teaching practice. The third one, which is the most relevant, I guess, based on the outcomes of this analysis, is that we should be looking for apps that contain explanatory feedback, plus there is progression that is scaffolded and personalized to each child. For policymakers, is the idea of how do you recommend apps that are of good quality and on stores, for example, like the Apple and Google Play stores. So should, for example, in the future be an indicator showing how good or how well designed an app is when they appear on those stores. And finally, if you are a researcher and you are looking for new ways of doing research in this area, I would say that we need more studies that are capturing the long-term impact of apps on learning, as only few studies had delayed measures of learning. It would be good if the focus is not typically developed children, but mainly underachieving children or children with SEND. It's crucial to capture the time children spend on a task, as this can differentiate outcomes in the analysis. And it would be nice if we could see more studies using mobile learning analytics and including this in their understanding of the app and its impact. Thank you so much for attending, and I would be more than happy to answer questions.